Right now, Tabby's star is still dimming, unpredictably, unevenly in ways that violate every rule we have for how stars behave. And scientists at NASA, Yale, and Caltech have no explanation that survives the data. They have watched it for years. They have run the models. And every single answer they came up with has been ruled out. But here's what nobody is telling you. KIC 8,462,852. That is its catalog name. You will never hear most astronomers call it that in public. You will hear them call it Tabby's star, named after the astronomer Tabby, who pulled it out of a mountain of Kepler Space Telescope data in 2015 and realized something was deeply, fundamentally wrong. The star sits 1,470 light-years away in the constellation Cygnus. It is bigger than our Sun, hotter than our Sun, and older than our Sun. On paper, it should be completely unremarkable. Millions of stars just like it, studied, cataloged, ignored. But Tabby's star will not stay quiet. It keeps doing something that stars are not supposed to do. And the more data we collect, the more certain we become that we do not understand what is happening inside it or around it. Stars dim. That is not unusual. When a planet crosses in front of a star, it blocks a tiny fraction of the light, maybe 1%, maybe 2%. Our instruments are sensitive enough to catch it. That is how we find exoplanets. That is the standard model. That is the rule. Tabby's star broke the rule. In 2015, Tabby and her team were reviewing 4 years of Kepler data, and they found dimming events not of 1 or 2%. They found dips of 8%, 15%, 22%, happening irregularly, happening unpredictably, happening in shapes no planet transit has ever produced. The light curves were jagged, asymmetrical, clustered into bursts that lasted days and then vanished. No known planet causes that. No known moon. No known asteroid field. Whatever was passing in front of this star was enormous, and it was not moving in any orbit we have ever seen. And that's not even the part that worries them. The first theory was comets. A massive swarm of comets, thousands of them, breaking apart and tumbling across the star's face in irregular clusters. It made some sense on the surface. Icy debris scatters light in strange ways. Astronomers ran the numbers. The numbers didn't work. To block 22% of a star's light, you would need a cloud of material larger than Jupiter. Comets do not come in that size, not even close. And the dimming pattern, that jagged, asymmetric signature, does not match debris clouds either. The signal looked more like something structured, something with edges. Something that was not randomly drifting but deliberately positioned. That is when the conversation shifted to a place most scientists do not like to go. In October 2015, a paper appeared. It came out of Penn State. The lead author was Jason Wright. The title was careful, measured, academic, but buried inside was a sentence that rewrote the next decade of astronomical conversation. The paper suggested that the dimming pattern of Tabby's star was consistent, not proven, but consistent, with a Dyson sphere under construction. A Dyson sphere, a megastructure built around a star to harvest all of its energy, the kind of engineering only a civilization millions of years more advanced than ours could attempt. The kind of structure that, if it existed, would explain every single anomaly in the data. NASA did not dismiss it. Yale funded follow-up observations. The SETI Institute pointed its arrays at the star. The scientific community, usually allergic to the word alien, let the hypothesis survive. And then the long-term data arrived. Historical photographic plates going back to 1890. Astronomers compared them, and they found that Tabby's star had been dimming steadily for over a century. Not just during events. Overall, the star itself was getting fainter, slowly, continuously, across 130 years of recorded observation. A megastructure does not explain that. A swarm of comets does not explain that. Nothing we have proposed explains that. And here is the part they are afraid to say out loud: we are no closer to an answer today than we were in 2015. If it is dust, interstellar dust absorbing light over time, then why is the short-term dimming so structured? Why does it cluster? Why those specific shapes? If it is the star itself, some internal process we do not understand, then we have never seen another star do this. Not once. not in the entire Kepler dataset, not in 2 centuries of stellar observation. If it is something artificial, something built, then we are not alone. We have never been alone. And something out there is 1,470 light years away, harvesting the light of a star, and we have been watching it work for over a decade without understanding what we are seeing. Every explanation carries a consequence we are not ready for. Either our physics is incomplete or the universe is more inhabited than we ever admitted. There is no comfortable middle ground. Tabby's star is still dimming. Right now. Tonight. The latest observations confirm it. No one has retracted the question. No one has closed the file. So what is it? What could dim a star like that for that long in that pattern and leave the world's best astronomers with nothing but silence?